Welcome viewers, in this video we will see the solved problem based on the slip of the 3-phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the first problem. A 3-phase induction motor is wound for 4-pole and is supplied from a 50 Hz subsystem. Calculate the synchronous speed, rotor speed when the slip is 4%, rotor frequency when the rotor runs at 600 rpm. Now we will analyze the given data. The number of poles is given as 4. Number of pole equal to P equal to 4. The supply frequency given as 50 Hz. So first we need to find the synchronous speed and speed of the rotor at 4% of the slip. Then rotor frequency. First we will see the synchronous speed. Synchronous speed ns equal to 120 f by p. Very standard formula available for a synchronous speed. So the number of poles and frequency is given. So that by using this formula we can able to find the synchronous speed. So 120 f by p, that is equal to 120 into the frequency is 50 Hz divided by number of poles equal to 4. Right. So by simplifying this, what we got, 1500 rpm. So the synchronous speed of the 3-phase induction motor for the given data is 1500 rpm. Next we will find the rotor speed at 4% of slip. 4% of slip means 0.04. Slip value is 0.04. Right. So the rotor speed can be calculated from this formula, n equal to ns into 1 minus s. This formula relating the synchronous speed and slip. From synchronous speed and slip we can able to find the rotor speed. So these two data are available. So by using the formula we can able to find the rotor speed. So ns is 1500. Now just now we calculated into 1 minus the slip is 0.04. So 1500 into 1 minus 0.04. By simplifying this we got 1440 rpm. So the synchronous speed is 1500. Because of the slip, the motor rotates at 1440 rpm. Now we will find the rotor frequency for a given speed of 600 rpm. For a given speed of 600 rpm, we need to find the rotor frequency. First we will find the slip at 600 rpm. If the speed is 600 rpm, what is the slip? The general formula is S equal to ns minus n divided by ns. The difference between synchronous speed and rotor speed divided by synchronous speed will give the value of slip. So the synchronous speed is 1500. That's now we calculated. The speed is given as 600 rpm. So 1500 minus 600 divided by 1500. So it is about 0.6. The slip is 0.6. For the given 600 rpm, the slip of induction motor is 0.6. So with this data we can able to find the rotor frequency. Fr. F refers the frequency of the supply system. Fr refers the frequency of the rotor. The formula available, Fr equal to S into F. Slip into frequency. The slip is what we calculated 0.6. So 0.6 into 50. The frequency is 50. So 0.6 into 50 it gives 30 Hz. So the frequency of the rotor is 30 Hz. So now we calculated all three parameters: synchronous speed, rotor speed at 4% of slip, and rotor frequency at the speed of 600 rpm. Now we will go to the second problem. An 8-pole 3-phase induction motor is supplied from 50 Hz AC supply. On full load, the frequency of induced EMF in rotor is 2 Hz. Find the full load slip and corresponding speed. So the first we will analyze the data. The number of poles is given, P equal to 8. The frequency of the supply is 50 Hz and the rotor frequency is given 2 Hz. We need to find the slip of the induction motor for that corresponding speed of the induction motor. First we will find the slip of the induction motor. We know that the Fr equal to S into F, because we need to find the slip. The two data available is rotor frequency available and the supply frequency is available. So, by using this formula we can easily calculate the slip of the induction motor. So, Fr equal to the frequency of the rotor equal to slip into supply frequency. So, from that S equal to Fr divided by F, rotor frequency divided by F. The rotor frequency given 2, the supply frequency is 50. So, 2 divided by 50 it is 0.04, that is nothing but 4%. So, for this given data the slip of the induction motor is 4%. Now, we need to find the corresponding speed, the corresponding rotor speed. Before that we will find the synchronous speed, so that we can able to find the rotor speed. So, synchronous speed ns equal to 120 f by p, very standard formula available. This f is nothing but supply frequency divided by number of poles. So, 120 f by p means 120 into frequency is 50, number of poles 8. So, by simplifying this what we got, 750 rpm. The synchronous speed of the in the 3-phase induction motor is 750 rpm. Now, we can able to calculate the rotor speed. For this the slip is 4%, synchronous speed is 750. So, by using these two data we can able to find the rotor speed. Slip means the speed of the difference between the rotor speed and the synchronous speed. So, n equal to ns into 1 minus s. The formula relating the rotor speed, synchronous speed and slip is available. So, these two data are available. So, we can easily calculate the speed of the rotor. So, n equal to ns into 1 minus s. So, n equal to ns is 750 into 1 minus s. 1 minus s is 0.04, 4%. Right. So, by simplifying this what we got, 720 rpm. So, the synchronous speed is 750, because of 4% of slip the speed reduced to 720 rpm. So, in this problem we calculated the slip and the corresponding rotor speed. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.